This is Math 3, 2.3b notes. That's Math 3, Unit 2, Lesson 3b notes. The title is Solve Absolute Value Inequalities Continued, because we started this on 2-3a, 2.3a. Make sure you put your name and period number in the upper right-hand corner. And again, obviously there's no handout for this lesson. Solve and graph, write solutions in interval notation. Okay, number 1. Absolute value of x is greater than or equal to 5. All right. For now, I'm just going to show you how to set them up. When we're in class together, I'll show you more of the how and the why we set them up this way. Okay, so for now, I'm just going to give you the shortcuts, the basics, how to get this done, and then we'll go over more of the how and the why in class. Okay. Whenever you see an absolute value with an inequality, this is what you're going to do. Absolute value with an inequality, you're going to think of what that symbol is. As long as x is coming first, you're always going to read it from left to right. You want to make sure x comes first in order to do this. So the absolute value of x is on the left side. Greater than. All right, so I'm going to write it down. That's greater than. That symbol is greater than, but I'm going to write it greater than. Greater than. And I'll put quotes around the whole thing. Greater instead of greater. Greater than, and there's a reason I'm writing it like that. Greater than here's what you're going to do. You're going to take it as it is without the absolute value. X is greater than or equal to 5, and you're going to write the word or in between, and then you're going to take it and you're going to change two things. That inequality is going to flip and the 5 is going to become negative, and that's how you're going to solve it. All right, so whenever the x is first, the absolute value, and it's greater with greater than equal to or just greater than. It doesn't matter if the equal bar is there or not. If that symbol is gobbling up the x, then it's a greater than. You're going to use the or. All right, and how do we graph this? -5, the smaller number always comes on the left and the larger number always goes to the right. They're closed circles because of the equal bar. And this is wanting me to graph everything greater than 5. Everything greater than or equal to 5. So that's everything that way of 5. This one is asking me to graph everything to the left of -5. X is less than or equal to -5. So it goes that way. All right. And it's perfectly fine for ors to go in opposite direction like bunny ears. They don't always do that, but it's okay if they do. Other problems cannot, but for oars, think of boat oars. You know, they're facing out towards the water and you're rowing your boat. Okay, or bunny ears, however you want to think of it. Oars are the only ones that can do that. They don't always do that. Sometimes you don't rewrite yours, but sometimes the oars do this. And that's okay. They go in the same direction. Sometimes oars go towards each other, and that's okay. Oars can pretty much do anything they want, but most of the time they're going to look like bunny ears or boat oars. All right. And write our solution in interval notation. So here's the graph. We solved it. We graphed it. And interval notation is what we've been doing. And it looks like this. -infinity to -5 with the bracket, parentheses there, union 5 to infinity, bracket, parentheses. Everything to the left is -5. Everything to the left of -5 is infinity. So -infinity to -5, bracket, union 5 to infinity. All right, number 2. Absolute value of x is less than 5. All right, we're going to think of this as less than and. Yes, we call it less than, but we're calling it for now less than and, greater or. So greater ors are ors, less than ands are ands. And I'll go ahead and put an equal bar. It's not necessary, but I'm going to put them there for now. All right. So whenever you see this, you can do the same thing you did over here. X is less than or equal to 5, just as it is. And then instead of or, we're going to put and. X is, we're going to flip things around, greater than or equal to, and then a -5. So it's going to look like this. All right. Now, when you graph ands, you have to remember that ands must have overlap. If there's no overlap, there's no solution. Your solution for an and problem is where they overlap, which is why you need it to overlap. All right, smaller number comes first, so that's -5 here, +5 there, and they're both closed circles, and they're both closed circles because of the equal bar there and there. All right, and then this one, I'm going to do the negative one first. X is greater than -5 means everything to the right of -5. X is less than or equal to 5. Here's the +5, and less than is everything to the left. And what did I just say? There needs to be overlap. Where do they overlap? Everything in the middle. So there's two ways you can graph this. You can graph it like a little rainbow like this, or some kids will just shade in between. You don't have to do both of them. You pick one. You show the arrows or you shade in the outer direction. It's your choice. All right, so this one I did like a rainbow, and so my solution is everything between -5 and 5. So try a number between -5 and 5. 4 is in between. The absolute value of 4 is less than or equal to 5. What about -4? -4 is in between those two numbers, and the absolute value of -4 is +4, which is still less than or equal to 5. Anything out here is not going to work, like 6 or 7 or 8, which you can see. The absolute value of 6 or 7 or 8 is not less than or equal to 5. The same thing with -6 or -7 or -8 is not going to work because that absolute value is not going to be less than or equal to 5. So we're going to write it like this in interval notation. So you have two answers, your graph, well, three, your solving piece, your graph, and then your interval notation. All right, so number 3, the absolute value of x is greater than -5. And we can put the equal bars there again. We'll see some without in just a little bit. Okay, x is greater than or equal to -5. What does that mean? Greater or, that's an or problem. X is greater than or equal to -5, or x is, and you flip the inequality, less than or equal to +5. And we graph. The negative number comes first, the larger, or the smaller number comes first, the larger number comes second. It is closed because of the equal bars. Greater than -5 is everything to the left. Less than +5 is everything to the left. And I don't know if I said that wrong earlier. This one's everything to the right. This one's everything to the left. Okay, so greater than -5, everything to the right. Less than or equal to +5 is everything to the left. Now here's what you have to remember. Ands are the only ones that must have overlap. Remember what I said earlier about ors? Ors can do anything they want. They can go opposite direction. They can go in the same direction. They can go towards each other. They can pretty much do anything they want. They don't have to overlap like the ands do. So if that's the case, I'm going to shade any number that's bigger than -5, or any number that's smaller than +5 that ends up being the whole number line. It's everything. So it's -infinity to infinity. And we always use parentheses. Even though there was closed circles there, we ended up with -infinity to infinity, which is parentheses. All right. Number 4. The absolute value of x is less than or equal to -5. Remember, less than and is an and. The first one we always take exactly as it is, just drop the absolute value. Less than and, this was greater or, so I'm going to write and here, and it's important to always write that because if you forget it, you're going to get points docked off. Okay, then you take the x, you flip the inequality, and it's +5. And let's graph that. Remember, ands must have overlap. There's the -5. And so the -5 comes first because it's smaller than +5. -5 closed in, +5 closed in because of the equal bars. And this is saying I want everything less than or equal to -5. And at the same time, I want it to be greater than or equal to +5. Now, with the ands, what did I say earlier? There must be overlap. Can you see that there's no overlap? Which makes sense because there is no number in the world that's smaller than -5 and at the same time greater than positive 5. It's mathematically impossible, so this would be no solution. So there's your graph, no solution. So when ORs look like AND problems and they go towards each other, negative infinity to infinity. But when ANDs try to look like ORs and go away from each other, it's no solution. It's not possible. ANDs cannot do anything they want like the ORs. All right, so that one there is no solution. So a quick way to remember this, so I mean, you could do all the work every single time, it's going to work. But if you have an absolute value greater than a negative, rather than doing all the solving, you can say, hey, that's always going to happen. Absolute value is always positive, and any positive number is going to be larger every single time. It's going to be larger than negative 5, so negative infinity to infinity. Absolute value is always positive, and positive numbers are never ever going to be smaller than a negative number, ever. Positive numbers will never be smaller than a negative 5, so no solution. Again, the work helps, but once you get the hang of it, you can use that shortcut. Okay, number 5, the absolute value of 2x minus 17, closed absolute value is greater than 5. All right, I am going to take a look. That's greater or, that's an or. So 2x minus 17 is greater than 5, or 2x minus 17 is less than negative 5. Okay, exactly as it is without the absolute value. And then you flip the inequality and change the opposite. All right, add the 17. 2x is greater than, what is that, 22? Divide the 2. X is greater than 11. Or, let's solve this one, add the 17. 2x is less than, what does that become, positive 12? Divide by 2. X is less than 6. All right, we solved it. Now let's graph it and write our answer in interval notation. All right, smaller number comes first, so that's 6. This is 11, and these circles are open because there's no equal bar on it. I'll do the 6 first. X is less than, that means it's going to the left, less than 6. X is greater than 11, that means all the numbers to the right. And it's okay for oars to look like boat oars or bunny ears. That is okay. So negative infinity to 6 with parentheses on the 6 because it's an open circle, union 11 to infinity. All right. And next one, absolute value of 4x plus 1, close absolute value. Oh, I'm going to change that. No, we're good. The absolute value of 4x plus 1, close absolute value, minus 12 is less than negative 7. All right. Now, here's what we haven't seen yet. To see how there's stuff around and there's negatives, and kids might be like, oh, let's look at the shortcuts. You don't do any of the shortcuts or the ands and ors until you isolate the absolute value. Remember, we have talked about that before. Always isolate the absolute value before you do any kind of ands or ors or shortcuts. Always isolate first. So we're going to add 12 to the other side. Absolute value of 4x plus 1 is less than negative 7 plus 12 is 5, positive 5. So we're not going to use any shortcuts. We're actually going to go through and work it out. Okay, so here is where you look. This is less than and. Less than and is an and problem. Doesn't matter if the equal bar is there or not. 4x plus 1 is less than 5, and 4x plus 1, we flip that less than to greater than, and that positive 5 to a negative 5, and now we're going to solve each one. All right, you're going to subtract 1, giving you 4x is less than 4. Divide by 4. X is less than 1. And over here we're going to subtract 1. 4x is greater than -6, divide the 2, and it's okay the 4. It's okay to get a fraction answer. Fractions are our friends, remember that. Okay, so divide by 4, and you do have to, with fraction answers, reduce if possible. X is greater than, you can divide by 2, so that's -3/2. All right, remember ands must have overlap. If there's no overlap, then it's no solution. -3/2 is smaller than +1. They're both open because there's no equal bar. I like to graph the left side first. X is greater than -3/2, that's everything to the right. X is less than +1, that's everything to the left. And where does it overlap? In the middle, like it should. Ands overlap. And then so it's -3/2, comma 1 with parentheses because both the circles are open. All right. That is it for this lesson. Make sure you get this turned in because we're not finishing it in class, so it's ready to turn in now. And again, make sure you put your name in the upper right-hand corner. That is it for this lesson.